Students. So let's look at another example to understand the concept of comparison by division. Let's say we are trying to compare the number of girls to the number of boys in a class, and this is what the data is for two different years, that is 2015 and 2016. So in 2015, it was found that there were 3 girls and 7 boys in the class. So total students in the class were 10. Now, when the same report was fetched in 2016, it was found that there were 6 girls and 19 boys. Now, the total students in the class was 25. Just by looking at the numbers, we see that number of girls have increased. Yes, number of boys have increased also. Now, if I ask you, do you think that the ratio of girls when compared to boys have increased in 2016? Like in 2015, there were 3 girls for 7 boys. Now in 2016, the number of girls has increased. So if you compare just by difference, what you will see. Here in 2015, we have 3 girls, and 2016, there are 6 girls. So 6 minus 3 is 3, and you can say that number of girls have increased in 2016 by 3. But at the same time, number of boys have also increased. Now, in order to see whether the number of girls have increased with respect to the boys or not, what we need to do? We need to consider ratio. That means whenever we need to find out if the number of girls with respect to the number of boys have increased or not, then we make use of comparison using division. That is, in 2015, what was the ratio of girls? Means how many girls were there with respect to the number of boys. So see, there were 3 girls for every 7 boys in 2015. And what was the ratio of girls with respect to the number of boys? And see, there are ratio of girls with respect to the number of boys. So number of girls is 3 and number of boys is 7. So ratio will be 3 by 7. And what will be the ratio of girls with respect to the total number of students? So number of girls is 3 and total number of students is 10. So ratio would be 3 by 10. Right, in 2015. Now what happened in 2016? If we calculate the same ratio in 2016, that is ratio of number of girls to the number of boys in 2016, and that is 6 by 19. And ratio of girls to total number of students, that would be 6 by 25. Now when you actually start calculating these values, you can actually now compare these numbers, whether 3 by 10 is bigger or 6 by 25 is bigger. Similarly, whether 3 by 7 is bigger or 6 by 19 is bigger. So when you actually compare 3 by 7 with 6 by 19, you find that 3 by 7 is greater than 6 by 19, which shows that in 2015, number of girls with respect to number of boys were better. At least for 7 boys, there were 3 girls. Now in 2016, for 19 boys, there are only 6 girls. So the ratio has actually decreased all the more, even though the number of girls has increased from 3 to 6. But the ratio of girls with respect to boys have decreased. Now I hope you got the concept of ratio. Ratio is always comparison using division. So whenever you divide a particular quantity with respect to some other quantity, that is where ratio comes in picture. So these were some examples with which we understand that ratio plays a very important role for comparing quantities. Now what is ratio? A ratio is a comparison of two quantities in terms of how many times. Like whenever we use ratio, it's about dividing two different quantities, just to tell that how many times of one quantity is the other. So that kind of comparison happens in case of ratio. Let's take an example. Let's say there are two friends A and B, and let's say height of A is 150 centimeter and height of B is 130 centimeter. So if you say what is the ratio of height of A with respect to height of B, so the ratio would be height of A divided by height of B. That's 150 divided by 130, and 0 0 will get cancelled and you will get 15 by 13. So how do we denote ratio? We denote it in this format: 15 is to 13. This is to. So 15 is to 13, that means 15 by 13. 15 corresponds to the height of A and 13 corresponds to height of B. It doesn't mean height of A is 15 centimeter. It just means that when you divide height of A by height of B, this is what you would get after division. This is like the ratio in its simplest form. Similar, if I take another example, if you see that height of A is say 2 times height of B. Now what would be the ratio of height of A to height of B? So we don't know the heights of A and B here in the second case. So let's assume height of B is x. Then by equation height of A is twice B, 2 times height of B. So if I am assuming height of B is x, then the height of A would be 2x. So now what will be the ratio of height of A to height of B? 2x divided by x. X will get cancelled and you will get 2 by 1. And 2 by 1 will be represented as 2 is to 1. So this shows that height of B is 1, then height of A would be 2. These are not the actual height, they just tell the ratio between their heights. Now one more interesting thing is that whenever you are comparing two quantities, their units must be the same. So you can never compare two different quantities with two different units. For example, let's say height of A is given as 150 centimeter and height of B is given as 1300 millimeter, 1300 millimeter. Now you have to find out the ratio of height of A to height of B. So 150 centimeter divided by 1300 millimeter, you can't find the ratio. Then what should you do? You will have to do something so that you are able to convert one of these such that both the heights are in the same unit, because they are not in the same unit. So let's say you decide to convert millimeter into centimeter. And we know that 1 millimeter is equivalent to 1 by 10 centimeter. So therefore 1300 millimeter will be 1300 divided by 10 centimeter, right? And 0 0 will get cancelled, you will get 150 by 130. Again 0 0 will get cancelled and you will again get 15 by 13, or 15 is to 13. So what is ratio? Comparing two quantities in terms of how many times, and it's denoted by the symbol is to. And most importantly, for comparing any two quantities in a ratio, their units must be the same. Even if they are not same, convert them such that they are same. Now most of the times children get confused between ratio and fraction because both of them look similar. We say that 1 by 2 is a ratio, 2 by 1 is a ratio, 2 is to 3 is a ratio, and all of these look exactly like a fraction. So how is a ratio different than a fraction? Now a ratio compares two quantities. So wherever you talk about ratio, you are actually comparing two different quantities. Whereas when you talk about a fraction, it gives part of a whole. Now these two sound like a general definitions of ratio and proportion. So let's take an example. Let's say this boy named A and ate one slice of pizza out of 5 slices. So basically he ate 1/5 of pizza. So what is this 1/5? So this 1/5 is not a whole number now. If I say 1, that is a whole number. That's one complete pizza. So 1/5 is a fraction. Let's say that there is another boy B who ate 3 slices out of 5 slices. So he ate 3/5 of the pizza. So again here also in the similar way, 3 by 5 is a fraction. So what do we see? Fraction is always about part of a whole. But what about ratio? Now if I tell you that you have to compare the amount of pizza eaten by A to the amount of pizza eaten by B. So what is the ratio here? So if you find out the ratio, now why are we finding this ratio? We will find this only when we want to compare the amount of pizza eaten by A and B. means when we want to compare. Now comparison at one level would be this, that 3 by 5 is greater than 1 by 5. This is one type of comparison. But that means B ate more pizza. But how much more pizza did B ate than A? So if you want to compare by division, that means how many times more did B eat than A. So how will you find that ratio? So ratio of pizza eaten by B to the pizza eaten by A would be 3 by 5 divided by 1 by 5. And 3 by 5, write 3 by 5 as it is, and divide gets changed into multiply, and whenever we write multiply instead of divide, the fraction, the reciprocal of a fraction changes into its reciprocal. It means 1 by 5 will be written as 5 by 1. 5 will get cancelled and you will get 3 by 1 or 3:1. Therefore, pizza eaten by B to A is 3:1. So 3:1 is a ratio because it's comparing two quantities. So these two different quantities altogether which are getting compared, but in case of fraction, fraction is like a number that how much pizza did A eat. So 1/5 is considered a one complete number, but here when you say 3:1, it's not a number, one number. 3:1 determines where 3 tell you the amount of pizza eaten by A and 1 tell you the amount eaten by A. B and A. These are not exact amounts, but they give you an idea about how much did A eat, B eat respectively. So this is how ratio is different from a fraction.